Hey again guys, and welcome back. In the last video, we added this LCD display to the DHT11 project. And I think the next step is to move it from something that is so large, like this big, and make it a little bit smaller. Now our LCD is as small as these types of LCDs go. We could try to put an OLED in there. If you want to see this project with an OLED instead of this LCD, let me know in the comments below. But for now, I think we need to shrink this portion. This Arduino is massive. The Arduino Uno, I always say, is the best platform to prototype with, but for permanent installations, I much prefer a DigiSpark or a Pro Mini. I think in this case, though, we are going to go with the Pro Mini. So if we can replace all this bulk with this, it's almost as if we'll be able to mount everything kind of in the footprint of this LCD. But I think the first thing I want to do is take some baseline measurements, because I feel as though, because we don't have the USB to serial components on this one here, we're going to use a lot less current. And if we use less current, that means we could probably drop our power source to something much smaller, or make it run for longer amounts of time on the same power source. So this thing here is telling me that we're taking roughly 20 milliamps, although I don't know how accurate this thing is. So we can ditch this power supply, at least for now, and I'll bring in a just a breadboard power supply, simply because we can use the smaller form factor here to see if we can get this thing reading. Now I need some jumper wires. Here is a male-to-male for the positive. So this here is set to 5 volts, so we'll go right from here and we'll just drop it into one of the female pins here, just the holes. VIN and 5 volts should be the same, considering this will just be taking 5 volts. And then to measure the current, I've got a slightly more reliable multimeter. I'm not sure if this thing is entirely more reliable, but it's something. Take the glare off the screen a little bit there for you. Moving all this precarious stuff over a bit. Now to measure current, we have to go from the ground rail here. Am I properly in the VIN? Yeah, I am. Go from the ground rail here, through the meter, and then back to ground. And I can actually turn this off while I make the connections. And we're going to want to move. So this one is coming back from the ground and then through here. There we go. That's better. Okay, so we have 32 milliamps on boot up. And yeah, that's it. You could see a small spike in current draw when the sensor is being pulled, but still 32 milliamps is not much at all. This thing is sipping current. I'm hoping that the Pro Mini will take even less current than this. And we can do things like turn off the backlight, but I kind of want to be able to just look at this from a distance. Well, that's pretty good. All right, now that we have our baseline, we should try to program the Pro Mini and see what we get. So I think the first thing I'm going to do is actually program the Pro Mini, and then we can do all the connections and see if it worked. So let me bring you back over to the computer. So here we are where we left off on uploading our software to the Arduino Uno. So I just need to change everything. I've got the Pro Mini installed now, plugged in. So we need to change this to USB ASP. We need to change this to Pro Mini. And we change our COM port to the COM port for the CH2102, I think it is. If you need a tutorial on how to program these Pro Minis, I made a little video a little while ago, so maybe I'll link it up in the description and up here on the screen if I remember. So theoretically, the Pro Mini has an ATmega 328P, so it's the same chip as on the Arduino Uno. So everything aside from changing your COM port and your programmer should be the same. So let's see if it'll actually upload. Done uploading. So it looks like it was successful. So now let's go back to the bench, make our connections, and see if this device actually boots the way we left it. So now that our Pro Mini should be programmed, we can go ahead and connect all these things together. Now, the only big difference between the Uno and the Pro Mini that might make your life a bit more difficult is that SDA and SCL are on A4 and A5 instead of having hardware pins broken out. So if you go over here, our white and brown are SDA and SCL, and since our SDA is white, we need to put that into A4, and our SCL is brown. We're going to put that over here. Now, a little bit of a precarious thing here is that we have to make sure we have enough positives and negatives, because we need a positive negative for the screen, a positive and negative for the DHT11, and we need to feed this power somehow. In the final product, when we put this all together, these are going to be actually powered by traces on a board or separate wires, but because we're just still in the prototyping phase, I'm just going to poke them into whatever holes I can find here. So I see a VCC and a ground there. So I'll poke this into the VCC and poke this one into the ground. So we should be good to go as far as the screen is concerned. For the sensor itself, well, we know that we need pin 2 for the actual digital pin, like that. And then we need a VCC and a ground for this as well. So I can see here there's a ground there, right by this pin over here, right next to the pin 2. So I can pop that in. And then we need a source of 5 volts. And there's not much left. There's this raw pin, which I might use, and then reconnect my connections that fell off here. We'll see if that works for us, because we're going to feed in a regulated 5 volt supply. I think it's okay to use the raw. We will see. Pop this back into the ground. And I realize this is super precarious, but that's okay. I'm just doing this again because it's a prototype. So next, I'll turn off this power supply, put the 5 volt line in, and I'll put that into VCC on the programming header here. So that's into VCC. And now I need my current measurement, because I'm hoping it's going to be lower current. The other one was in the 30-some milliamps. So we're going to grab this coming from the ground on the programming header and pop the other side into the ground of the power supply. Alright, so now I'm not sure if this is going to work, so only one way to find out. It is working. There we go. We have our reading. Now something that's weird is that the contrast is a bit different between this one and the other one. So the Uno and the Pro Mini has like a different contrast setting, I guess. But I think this one's manually adjustable. So I'll flip this around and I'll spin the little pot here. Oh, we did pull something out here. Got to put the ground back in. That's the problem when you do things precariously like this. Okay. Oh, and now we lost our DHT. This is just a mess, isn't it? There we go. It's rebooted now. So yeah, it's taking actually a little bit more current, and I'm not sure why that is. It's not like these guys are touching. In fact, these connections are a little bit unstable. Yep, don't know. It does seem to take a little bit more current. So it's possible that this chip, the SMD and the smaller footprint, is a little bit less efficient, or if it's running maybe a less efficient regulator. But at least now we know that we have about 50 milliamps of current. There's things you can do, I think, to drop this, like maybe changing the rate at which the screen refreshes. But I think for now we're going to go with a 50 milliamp draw and kind of use that as our baseline when we pick our power solution. But I think this is all way too precarious, so in the next video I think we're going to make a nice board for it. Either that or just wire it up dead bug style, but regardless, clean it up. So I think that's it for now, and I want to thank you all for watching, and I hope to catch you in the next one.